All right, welcome back. So what we're going to think about now is how do we design that solo pong game in a top-down manner, okay? So a good place to start is to start from what you already know. So given the way the program demo that I had behaved, or even the sketch that we looked at, we probably could figure out that our solo pong game is going to need at least three methods: a setup method, a draw method, and a mouse move method. Okay, so setup does the initial stuff, sets all our variables, whatever it needs to be done before the game happens. The draw method will give us our different motion pieces, right? It takes care of the ball moving and the paddle moving. And then mouse moved will be the part that actually responds to the mouse movement of the user to move the paddle. Okay? So that seems like a good place to start for our initial decomposition of the solo pong game, which is our big problem, into three sub-problems. So now I don't have to think about solo pong as a whole. I can think about the setup part, then the draw part, then the mouse move part. Okay? So we won't be going through all of the details on this that are in the chapter, but you should really look at and carefully read those parts in the chapter to look at all the different variables that there are, why they're needed, etc. Okay? So do take a look at the chapter before we go much further. If you need to, go ahead and pause and then come back. All right, so this is an initial class diagram for our solo pong game, and it's got a whole bunch of class variables here, and then our three methods, the setup, draw, and mouse moved pieces, okay? So a lot of these are constants: the size of the ball, the thickness of the wall, paddle width, the maximum speed, and the colors for the ball and the walls, okay? Those are all constants. Everything else are variables, and these have to do with, for instance, the position of the ball, the X and the Y position. Delta X and delta Y are the speed of the ball. Paddle X and paddle Y are the locations of the paddle. And then the rest of these, paddle call X, call top Y, call bottom Y, etc., all of these are variables to be used for collision detection to tell when the ball runs into the paddle or the wall, west wall or the north wall or the south wall, okay? So those are all pieces then that are required for this. And so, again, look at the text to see where those came from. There's a discussion of where did we get those values and why do we need them, and some diagrams that you can use to follow through. Okay? So if we assume that we have that, then what we can do is we can start to think about, well, what does setup look like, right? We've got three methods. Let's take a look at what setup looks like. Well, here's an algorithm for this. And what we've done is we've divided it up into sub-problems, because if we talked about all those variables, right, all those variables need an initial value to begin the program with, well, that would make for a pretty long setup method. A rule of thumb is that if we write our method and it's going to be longer than a single page or a single screen on your computer or a printed page, then that's a good candidate for something to be broken up into sub-pieces, okay? So we're going to do some just generic stuff like set the size of the window, the colors, and the rectangle mode so that the rectangles will be sketched in a particular way. And right off the top of my head, I can't remember if, I think it's center mode, so that the XY that we provide is the center of the rectangle rather than the corner. But then after that, we're going to have sub-methods. A sub-method to initialize everything about the ball, a sub-method to initialize everything about the walls, and then a sub-method to initialize all the variables about the paddle. Okay? So we're dividing it up into these sub-methods, and if we look at our method hierarchy that we were developing, now all of a sudden it looks like this. Our overall problem is a solo pong problem, which we decomposed into a setup, a draw, and a mouse move method. And then we further decomposed setup into a knit ball, a knit walls, and a knit paddle. Okay? So again, what we're trying to do is end up with methods that are self-contained modules that don't do anything else but their one particular task. okay? And so we've done that decomposition on setup, leading to this method hierarchy. And then we might look at the draw method, right? To see if we can break that up into smaller pieces. Well, if we think about it, there's probably three things that we have to do in here. We have to draw all the items, update the ball's location so that the next time the draw method is called, the ball will be in a slightly different location so that we get the illusion of it moving, and then handle any collisions that we happen to have. Okay, so that provides us with three sub-methods from the draw method. Draw the items, update the ball, and perform the collisions. Okay, so that's about where we are for the end of this particular portion of the text. And again, it's really important to go ahead and read this to make sure that you get where all those pieces came from. The next part then will be looking into our final design where we'll further decompose the collisions method and then also talk about these other methods, right? Because we've never written those before. We've written the built-in methods, setup, draw, and mouse moved, but we've never written yet a method on our own that we just created. And so that's what we'll cover, and then we'll look into our implementation. All right, so those will be on the next part, the next section, 6.2. You can see the readings and look for the videos as they are posted. See you later.